Good to have you on Planetterrian Daily, episode 47 for April 19th, 2026. Let's see what the latest research is telling us. Protein engineers created over 10 million data points in 3 days, dramatically accelerating AI-guided design of custom molecules. Researchers developed a high-throughput method that rapidly tests vast combinations of amino acid changes in a 50-residue protein, producing more than 10 million data points. This scale of information lets artificial intelligence models learn protein function rules far faster than traditional approaches. The resulting dense dataset comes from real biochemical measurements rather than simulations, which gives the artificial intelligence predictions higher reliability when moving into the wet lab. It compresses what would once have taken years of sequential experiments into a single 3-day run. This breakthrough opens new routes to engineer enzymes, sensors, and therapeutics with greater precision. The approach is particularly promising for longevity-related pathways such as proteostasis, mitochondrial repair, and senescent cell clearance, where finely tuned enzymes have been difficult to optimize. Teams can now iterate on dozens of candidate proteins per month instead of 1 or 2. It also democratizes protein design, giving smaller academic groups access to datasets once reserved for well-funded labs. Watch for the first peer-reviewed enzymes or sensors produced entirely by models trained on this new generation of ultra-dense experimental maps. While that breakthrough is reshaping how we design molecules at the smallest scale, another team just uncovered fundamental physics governing damage at the heart of our most advanced electronics. Scientists at the University of California, Santa Barbara identified the precise quantum mechanism by which energetic electrons break chemical bonds inside microelectronic devices. The work resolves long-standing experimental puzzles about why chips gradually lose performance over time. Energetic electrons had been observed causing degradation, but the exact quantum-level process remained unclear until now. This finding points toward new materials and designs that could make future electronics significantly more resistant to wear. It is a clear example of fundamental quantum physics being applied directly to real-world technology challenges. Staying with deep mechanisms, let's shift from the quantum world of silicon to the neural circuitry that makes social pain feel as real as physical injury. Most people assume the ache of being excluded is just emotional and therefore less real than a broken bone or burn. In reality, the brain uses overlapping neural circuitry for both social rejection and physical injury. The anterior cingulate cortex and insula light up in functional magnetic resonance imaging scans whether you stub your toe or learn you have been ghosted. Right now, as you listen, any fresh memory of exclusion is still sending signals down some of the same pathways that once warned your ancestors about ostracism from the tribe. That evolutionary cue carried genuine survival risk in our past. One memorable finding is that the intensity of social pain activates the same opioid receptor networks that mute physical pain. This is why the brain can temporarily dampen heartbreak with the same chemistry it uses for a sprained ankle. The shared hardware explains why loneliness reliably elevates inflammation markers. Chronic social isolation correlates with mortality risk on par with smoking. The practical takeaway is to treat meaningful relationships as core health infrastructure, not optional extras. The next time you see a headline about social prescribing or loneliness interventions, pay attention because the science shows these are measurable physiologic treatments. That shared hardware between social and physical pain reminds us how deeply our biology is tuned to connection. On a broader scale, one anthropologist is now framing human culture itself as a planetary force on par with geology. Anthropologist Earl Ellis argues that social and cultural innovations, from early fire use to global supply chains, have reshaped Earth's systems at a scale comparable to natural geologic forces. The perspective moves beyond viewing the Anthropocene solely through the lens of crisis. Instead, it highlights humanity's demonstrated capacity for coordinated, large-scale positive change. This framing offers a hopeful reframing of our species' role in Earth's future. It emphasizes that cultural evolution can be a constructive planetary force when directed thoughtfully. While culture operates at planetary scale, a new large-scale review is clarifying how men respond when their sense of masculinity feels under threat. A team led by researchers from RPTU University, Kaiserslautern Landau, and the University of Kassel synthesized data from 19,448 men across predominantly Western experiments. The meta-analysis examined 123 studies to clarify consistent patterns in behavior. When men perceive their masculinity as questioned, the work identifies reliable increases in aggression, risk-taking, and certain cognitive shifts. The synthesis provides a clearer evidence base for understanding these responses rather than relying on smaller individual studies. It adds rigor to behavioral science in an area often clouded by conflicting findings. Social dynamics shape health in many ways. Another recent study highlights critical gaps in public understanding that could undermine one of our most effective tools against infectious disease. A study documented widespread deficits in understanding vaccination status and acceptance of the measles, mumps, and rubella vaccine among patients in United States emergency departments. Misinformation and access barriers are cited as key contributing factors. The results raise concerns about declining population immunity at a time when measles outbreaks continue to occur. These gaps could undermine herd immunity if not addressed through better education and outreach. Emergency departments often see patients who are not regularly connected to primary care, making them important venues for catching these deficits. While vaccine confidence faces real challenges, new diagnostic tools are arriving that could help clinicians respond faster when infections do take hold. Kagan introduced a new test that simultaneously detects multiple pathogens responsible for bloodstream infections. The syndromic diagnostic is designed to speed diagnosis in hospital settings. Rapid, accurate identification can directly inform treatment decisions in high-stakes situations. It addresses a clear clinical need for broader and faster pathogen detection than traditional culture methods allow. This kind of tool could reduce the time patients spend on broad-spectrum antibiotics while waiting for results. Rapid diagnostics are one piece of the public health toolkit. Another new assay expands our ability to track a different kind of urgent threat. LabCorp released a rapid test capable of identifying fentanyl exposure within a 48-hour window. With overdose deaths trending downward but use remaining a significant public health issue, the assay offers clinicians and public health programs an expanded detection timeframe. The longer window compared with earlier tests could support better intervention and monitoring efforts. It provides another data point for programs working to reduce harm in communities still facing this challenge. From diagnostics to therapeutics, the rare disease community is also rethinking how we develop and test new treatments when patient numbers are extremely small. Traditional randomized, placebo-controlled trials with hundreds of participants are often impossible for ultra-rare conditions. Researchers and advocates are therefore developing and testing alternative trial designs that maintain scientific rigor while fitting the practical realities of limited eligible patients. These redesigned approaches aim to overcome structural barriers that have historically slowed progress in rare disease research. The work focuses on preserving reliability without requiring large cohorts that simply do not exist. Improving trial access is another piece of that puzzle. A new partnership is working to connect more patients with relevant rare disease studies. A clinical trial site network and health tech company called My Tomorrows will collaborate to increase visibility of rare disease studies. The partnership will streamline referrals from both community and specialist settings. It targets structural barriers that often leave patients unaware of potentially relevant trials. Greater awareness could help more people with rare conditions find studies that match their specific needs. While those efforts aim to expand access, a broad new review is raising hard questions about how much benefit one major class of Alzheimer's drugs is actually delivering. An evaluation of the entire anti-amyloid class found that benefits on cognition have been minimal across both approved and failed candidates. The comprehensive review adds quantitative weight to ongoing debates about how much disease modification these therapies actually deliver. It describes the clinical effects as absent or trivial in many cases. This analysis encourages the field to keep exploring other biological targets beyond amyloid for Alzheimer's treatment. Before we go, keep an eye on how these alternative trial designs for rare diseases perform in early implementations, as they could reshape how we test many future therapies. That covers today's science and health news. Share this with someone who's curious about the latest research. I'm Patrick in Vancouver. See you next time. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.